Welcome to part two of common types of corrosion we would expect to find in the oil and gas industry. My name is Chukwemeka Nafo. I'm a materials and corrosion engineer. Last time we looked at the external corrosion, common types of corrosion that we expect to see in the oil and gas industry. Today we'll be looking at the external corrosion that we'd expect to see in the pipelines and equipment. So what we'll be looking at today is mainly atmospheric corrosion, corrosion under insulation, external stress corrosion cracking, and hydrogen-induced stress corrosion cracking. So let's start with atmospheric corrosion. This type of external corrosion is a form of oxygen corrosion. It occurs where the surface are continuously wetted with aerated water. So what that means, just to explain a bit more, is where you have continuous rainfall, which is water, obviously, falls on a metal surface, and with oxygen being all around us. Once the surface continues to get wet from time to time, what you start to see is corrosion along on the surface of the pipeline, or even any materials as well that's metal. And that type of corrosion, which you all know as rust, is what we call atmospheric corrosion. Airborne salt contamination can also increase corrosivity and tendency to pit as well. So basically, if we've got salt, airborne salt, where do we get that from? Close to sea or close to the shore. We all have airborne salt around areas like that, and that can contaminate metals and then cause corrosivity. So with the presence of airborne salts, oxygen, and obviously continuous wetted surface can lead to corrosivity, which obviously causes pitting along the line. So where does this kind of corrosion threat occur? So structural surface, steel surface, handrails, we're looking at the oil industry now, walkways where that's all exposed to the atmosphere, pipe supports, external surface of process equipment are all at risk with atmospheric corrosion. The next type of corrosion we're going to be looking at is corrosion under insulation. This type of external corrosion occurs underneath insulation due to water ingress. This type of corrosion is very tricky to find because it's under insulation, so it can remain undetected for a very long time, and by the time you know it, you start having leaks, and this can be very, very catastrophic as well if that happens. To find it, to even detect it, you would have to take away all the insulation to be able to and find that this is actually happening. So it's not something that you can actually see with your naked eyes unless you take away sections of the insulation. So where does it occur? Basically underneath pipelines and equipment that are insulated. It mainly happens at the 6 o'clock position if you're looking at it from a pipeline perspective. So the next type of corrosion we'll be looking at is the external stress corrosion cracking. This type of it is an external risk to mainly stainless steel in wet, chloride, and oxygen-rich environment. If you go back to my previous part one of this video, I did talk about chloride stress corrosion cracking. These two types are related So they are similar in a way. So chloride stress corrosion cracking affects both the internal and also external. Metal parts with severe stress corrosion cracking can appear bright and shiny while being filled with microscopic cracks. And it is quite it can be obvious to people who know how to inspect this type of material to find that this material is actually going through a microscopic crack to be able to detect that stress corrosion cracking is happening. So where does this occur? Stainless steel equipment and pipelines are susceptible to stress corrosion cracking in chloride-bearing aqueous environments, in seawater handling systems, submerged or even marine atmospheric condition. Submerged or in marine atmospheric condition. So this type of corrosion is quite, you know, kind of like very common in stainless steel and obviously in duplex. So duplex steel. So there, but it all depends on the temperature operating condition of the materials which they are being exposed to. The next type of corrosion we'll be looking at is the hydrogen-induced stress corrosion cracking. This type of corrosion is a diffusion of hydrogen atoms through the metal leads to this type of corrosion. Higher temperature increases the diffusion of the hydrogen, and then CP or cathodic protection can increase susceptibility if the equipment or the pipeline are not coated. So where does this type of corrosion occur? Pipelines and vessels that are not coated are at risk of hydrogen-induced corrosion cracking. Poorly coated pipelines and vessels where cathodic protection are used are also very susceptible to this type of corrosion. So that's why, working in the industry, we always do, after the, either vessel or equipment has been coated, we always do inspection to make sure that this type of that the coating has been properly done, so that when we install cathodic protection, it does the hydrogen atoms that are being released from the cathodic protection doesn't cause this type of corrosion known as hydrogen-induced corrosion. I'd like to thank you for listening to this section of the part 2 of this video, and I hope you enjoyed it. In the future, I'll be with you. The next aspect of my presentation would be on how do we control this type of corrosion, and I hope you will join me next time for it. Thank you.